All right, so now we're just going to do some mixed practice. So this is going to be you doing a lot of the work because it's nothing new in terms of content-wise. But it's a video, so I'll do some explaining. Of course, biggest thing, make sure you're having fun. And obviously, you're having fun. You don't have to tell yourself to have fun because this is just fun. But solving puzzles, that's what we're doing. And this is reviewing of what we have learned. So I want you to simplify this. Pause the video, simplify, unpause when you're ready to discuss. Okay, so hopefully for this you ended up with secant of x as your simplified answer. How do we come up with that? Well, I have secant of x times cosine of x times tangent of x times cosecant of x, right? It's a single term with 4 different trig functions all multiplied together. So my default in this case would be change everything to sines and cosines, and I hope things will reduce or combine in a nice way. And in this case they do. So I changed secant to 1 over cosine, these cancel. Changed tangent to sine over cosine, and cosecant to 1 over sine, the sine of x is cancel. And so then I'm left with 1 times 1 over cosine of x times 1. I don't need to write the 1's except for here in the numerator. So I get 1 over cosine of x, which is secant of x. Next one, simplify again. So pause the video, unpause when you are ready to check. Okay, so hopefully we got the same answer of cotangent of x. Now let's talk about how did we get that. Well, we have sine of x times cosine of x over 1 minus cosine squared of x. So the numerator I'm just going to leave for right now, but the denominator, that is screaming at me for Pythagorean identity. Anytime you have a 1, subtraction, or addition, and a trig function squared, it's probably relating to a Pythagorean identity. So I think about my Pythagorean identities, and I realize 1 minus cosine squared of x is sine squared of x. So I'm going to change that. I left the numerator the same, sine of x times cosine of x, change the denominator to sine squared of x. Now the sine in the numerator and one of the sines in the denominator is going to cancel, and I'm left with cosine of x over sine of x, which conveniently is cotangent of x. Nice work. Next one. I want you to try this on your own. You're simplifying. Pause the video. Simplify. Unpause when you're ready to check. Okay, so assuming I did my work right, I ended up with sine of b. How did I get that? Well, first, I just distributed. I didn't see anything that was going to simplify right away. Now, I did have other options. I could have changed the cosecant into 1 over sine and the cotangent into cosine over sine and see that they have a common denominator and combine them, but off the top of my head, I couldn't see how that was totally going to help me, so I figured, you know what, let's just get rid of the parentheses, distribute everything, and then go from there. So I distributed. I would also point out there are steps in here where I could have combined them, but in terms of trying to demonstrate to you my thought process, I did them in multiple steps sometimes. Okay, so I distributed. I get cosine b plus cotangent b minus cosine b cosecant b minus cosine b cotangent b. Okay, now I changed the cosecant into 1 over sine, and I changed the cotangent into cosine over sine. My thought process on that was really, these were the areas where I had 2 trig functions multiplied together, so I wanted to be able to do something with that. And my go-to is change things to sines and cosines, so that's why I changed the cosecant and changed the cotangent. But I left these because I didn't know exactly what was going to happen yet. All right? So now, when I did that, though, I saw, oh, this becomes cosine of b times 1 over sine of b, which is actually cotangent of b. This is subtraction, this is addition. I know these are going to cancel. This one becomes cosine squared of b over sine of b, but cosecant of b is also 1 over sine of b, so now I have a common denominator between these two. So now I combine this into 1 minus cosine squared b over sine of b. 1 minus cosine squared b is sine squared of b. Sine squared of b over sine of b is just sine of b. Nice. Next one. Now we're back to verifying. So I want you to verify the identity. Work with whichever side you feel is better. Pause the video. Unpause when you're ready to check. Alright, so here I'm going to show you again 2 different ways in which I might approach this problem. So the first one, Both ways, I actually chose to work with the left-hand side. It is more complex looking to me. It is more complex looking, actually, just in general, not just to me. So, anyway, what I did was, I thought, okay, well, I know I'm trying to get a subtraction in my answer, and I know I need cosines and 1s, right? Right now, on the left-hand side, I have a sine squared, and I have a 1 plus cosine. Sine squared, though, I can change that into 1 minus cosine squared using my Pythagorean identity. Now, again, in my thought process, how do I know this is a good idea? I know it's a good idea because it's introducing the subtraction that I want, and it's getting everything into cosines. That's how I know it's a good idea. So, then 1 minus cosine squared of x is the difference of squares. That factors into 1 minus cosine of x times 1 plus cosine of x. The 1 plus cosines of x cancel, and I get 1 minus cosine of x equals 1 minus cosine of x. I verified my identity. Nice work. I'm proud of myself. Okay, what's another thought process I could have had? So again, if I look at the left-hand side compared to the right-hand side, one thought process would be, I need 1 minus cosine of x to be in the numerator. Right here, because that's what the answer is. So if I need this in the numerator, then put it in the numerator. However, I can't break the rules of algebra, so in order to put it in the numerator, I also have to put it in the denominator, right? Because if I multiply the numerator and denominator by the same thing, that's okay. So I multiply the numerator and denominator by 1 minus cosine of x. Now, because I know that I want this in the numerator by itself, I'm not going to distribute in the numerator, but I'm going to distribute in the denominator to see if I can get things to simplify. So I distribute in the denominator, and this becomes 1 minus cosine squared of x. 1 minus cosine squared of x is sine squared of x. The sine squareds cancel, and I get 1 minus cosine of x equals 1 minus cosine of x. There are other ways you could have approached this. Remember that, if you did something different, as long as you aren't breaking the rules of trig and algebra, that's okay. You know what the answer is, right? You're just trying to figure out how to get there. And there are different ways. All right, so this is our last one for this video. Now, this one, you might see this right here, and you're like, what the heck is that? That is a cofunction identity. Now, we haven't formally talked about that yet in this class. That's okay. It is on your sheet. So if you look at those identity sheets that we have, or your notes packet, but my hint is you are going to change this into cotangent of alpha. Okay, so tangent of pi halves minus alpha is the same thing as the cotangent of alpha. This 2 still stays here. So, given that, I want you to try to do the rest of this, verify the identity. Pause the video. I'll pause when you're ready to check. Sound good? All right. All right, so we get sine of alpha equals sine of alpha. Done, right? Call it a day? Well, let's look at how we came up with that. And so, what did we do? Well, again, the first thing I did was we need to change tangent of pi halves tangent of pi halves minus alpha into 2 cotangent of alpha. And the 2 was just from that. Okay, so then in the numerator, I also changed this cotangent of alpha into cosine of alpha over sine of alpha. How did I know that's a good idea? Well, I'm trying to get a sine of alpha. Here I have a cotangent. Let's change it into sines and cosines, right? Same old story again. Conveniently, or not so much, depends on how we look at it, when I did that, the sine of alpha is canceled, which was convenient that they canceled, but now I still don't have a sine of alpha. So I'm left with cosine of alpha plus cosine of alpha over 2 cotangent of alpha, but conveniently, cosine of alpha plus cosine of alpha is 2 cosine of alpha, so the 2's cancel now. Now I change everything to sines and cosines again, so I change the cotangent into cosine of alpha over sine of alpha. Since I have a fraction over a fraction, I multiply by the reciprocal of the denominator. Denominator goes away. Numerator, the cosines cancel, and I'm left with just sine of alpha. That's it.